All right, so now what we're going to do is look at the graphs. The first way you can bring up the chart of the linear regression model is you go to graphs and you go to fitted actual plot and then just go actual versus fitted. And here you've got your observations, which are in red, and the model, the fitted model, in blue. Before we continue, I'm going to bring up the other chart or show you the other way you can bring up the chart. So if you cancel that and you go to analysis and then you go to forecasts, and then without forecasting anything, you just click OK. Then here, what you'll see is two things came up. So the chart, which we'll look at in a second, and also the forecast. So basically what happened here is Gretel took your existing records. So here you got your 30 records, and it didn't print any information on the independent variables. So years of experience is not here, as you can see, but it does have salary. So the actual salary that was in your file. And then it's got the predicted salary. So the salary that the model is predicting for that record. And you can just visually compare them here, see the standard errors, 95% confidence intervals, if you like. And also what this would have done if you, in terms of prediction, why is it called prediction? Well, if you did have some records where there was an empty value for salary, say 31, 32, 33, then it would actually populate them for you. It would it would still generate a prediction, and that way you could, for instance, extrapolate what you have this line onto new salaries. So you could see what the salary would be for people with more years of experience than you have in your data set. So we're going to close that, and we're going to look at the graph now. So this graph is a bit more involved because it has a 95% confidence intervals here in green. So in short, in a quick summary, what happened here is originally we only had the red dots or crosses, meaning that that's how salary is dependent on years of experience. So basically, if you take 9 years of experience, then you can, using this blue line, you can predict where the salary for 9 years of experience will be. And what the confidence interval is telling us is that there's a 95% chance that that salary will actually be somewhere between these two green lines on this vertical 9-year line. So basically, it doesn't have to be on the blue line. And as you can see, a lot of the actual values are not on the blue line. Some are, but mostly they're not. But we know that according to our data, with a 95% chance, it's going to be between these two green lines. And also, what we can see here is that the blue line, if it were to cross the vertical axis, it would cross somewhere at that constant value that we looked at, which is 29,000 and something. So here we have it. It's actually 25,792. That's where the blue line would have crossed the vertical axis. And as you can see, well, of course, like there's not enough space here, but that's because this axis should be a bit more to the left. There, 0 would be somewhere here, so there would be enough room for it to cross. And years of experience, that's the slope. That's basically the angle at which this blue line is going. If years of experience were also basically the coefficient for years of experience. So if this value was more than $9,449, then the slope of the blue line would have been higher. If it were lower, the slope would have been lower, so it wouldn't be as steep. So this is basically saying that whenever you move from, say, from 3 years to 4 years, from here to here, your salary increases by approximately $9,500 from here to here. So that's how this whole simple linear regression works. Hope it all makes sense. Play around with the data, maybe run a few more of these just to get comfortable with it. And remember that we'll be working with this screen quite a lot coming forward. And I look forward to seeing you next time. Until then, happy analyzing.